Welcome. In this video, we will be going over the use of the spectrophotometer.
In the first part of our lab, we made our stock solution. You will not always need to make your stock solution. However, you need to remember that stock solution should be poured in a beaker prior to use, as it is incorrect lab procedure to take contents directly out of the stock solution bottle or container. Our next task involved making a series of dilutions from the stock solution. If you question your ability to perform a series of dilutions, go back and watch our lab video on dilutions. Once we have our series of dilutions, we will transfer them into our cuvettes. A cuvette is the vessel used to hold a small amount of our solutions in order for the spectrophotometer to measure our solution's absorbency. It is important to make sure that the solution is filled to the line, noting that the meniscus is resting on the line and not far above, resulting in excess.
Before scanning our samples and finding our absorbencies, we must set up the application to tell our spectrophotometer which wavelengths to scan across. We set our range of wavelengths from 800 nanometers to 200 nanometers. This wide range is necessary to scan across all wavelengths, which is important because it allows us to find our lambda max. Lambda max is the wavelength where a solution encounters the strongest photon absorption. This is important because it gives us an accurate number for measuring the wavelength of a specific substance. Another reason why we want to scan across all wavelengths is in order to have a wider range of data to compare to the tabulated data of other scientists. This helps in the identification of any unknowns, as you will likely use the data obtained with this standard practice of scanning across all wavelengths.
Now on to the main technique of our spec lab.
Step 1. Confirm that our spectrophotometer has been properly calibrated or zeroed by scanning our blank sample, which would be water. Step 2. For an accurate reading, we must clean the two sides of our cuvette. Step 3. We will open the spectrophotometer and carefully place the cuvette in the machine, making sure the clean sides are in line with the beam. Be extremely careful when transferring the cuvette in and out of the spectrophotometer, as it holds liquid that could damage the machine if spilled.
Step 4. Close the spectrophotometer before scanning the sample. Step 5. Scan the absorbance using the spectrophotometer. Step 6. Record the absorbency value for each sample scanned in your lab notebook. Step 7. Once again, be careful when removing the sample from the spectrophotometer and close the door to it. Step 8. Clean the area in the spec lab, making sure that the door is shut, nothing is left behind, and all the cuvette cleaning wipes are disposed of. Cleaning also takes place back in our traditional lab setting, making sure that all the equipment is placed back in its home and other items used in the lab are disposed of properly.
One concept that we can begin to talk about when discussing spectroscopy is the Beer-Lambert law. This law informs us of the linear relationship between the concentration and the absorbance of the solution. This is significant because it allows us to find the concentration that was unknown via measured absorption. Failing to zero our scans will result in inaccurate absorbency results, as the machine will be measuring the water cuvette or blank plus the substance when we only want the absorbance of the unknown substance, not the means of dilution and transportation. Beer's law is an equation that follows this linear relationship, so it can be comparable to y equals mx plus b. This equation is A, or absorbency as found by the spectrophotometer, set equal to epsilon times L times C. Epsilon is the molar absorptivity constant, which can be found using logarithmic functions, but is usually simplified with L, which represents the length of the sample or cuvette. These come together to act as the slope of our function. Lastly, C represents the concentration of our sample, which is either known or solved using this law.
Thank you for watching our lab video, and please enjoy this montage of us cleaning our lab area.